Hi, this is Victor and welcome back to my math tutoring channel. In this video, we will try to solve that integral, which is 1 divided by x to the power of 4 square root of x squared plus 1 dx. And the technique that I will be using is integration by trigonometric substitution. Before I use that technique, I'm going to give you a hint for trigonometric substitution. If you have square root of a square minus x square, like in that case, the x squared is this and this is my a here. So you will use x is equal a sine of theta, and you have to use the trigonometric identity formula, which is cos square of theta is equal 1 minus sine square of theta. And if you have square root of a square plus x square, like this example here, where a is equal to 1 and x square is equal to x square, I will use x is equal a tan of theta. And the trigonometric identity formula that I will be using is sec square of theta is equal 1 plus tan square of theta. And if you have square root of x square minus a square, I will use x is equal a sec of theta, and the trigonometric identity is tan square of theta is equal sec square of theta minus 1. Let's delete this. So now that you have this, I know that I have in my denominator here, this here, I will take this. I have x squared plus 1, which is a squared plus x squared. I have to take x is equal a tan of theta, where a is equal to 1 in that example. So let's say x is equal 1 times tan of theta. So my dx would be sec square of theta d theta, because the derivative of tan is sec square. Now I will replace my x by its value. My integral become integral of 1 divided tan to the power of 4, because 1 times tan is tan, square root of tan to the power of 2 theta plus 1. And remember, and here instead of dx, I'm gonna write sec square of theta d theta. And remember, I told you we have to use the trigonometric identity formula. I have to use 1 plus tan square of theta is equal to sec square of theta. So here I have 1 plus tan square of theta. I have to substitute it by sec square of theta. So my integral become integral of sec square of theta d theta divided by tan to the power 4 of theta and the square root of sec square of theta. But I know that square root of sec square of theta is sec of theta. So my integral become sec square of theta d theta divided by tan to the power 4 theta sec theta d, I put the d theta, sorry. So now I can simplify sec theta with the square here. So the integral become integral of sec theta divided by tan to the power of 4 theta and d theta. Now I know that sec theta is equal 1 divided by cosine theta. So I will replace sec theta by 1 divided by cosine theta. I have d theta here, and the tan is sine theta divided by cosine theta. So it becomes sine to the power 4 theta divided by cosine to the power 4 theta, because I have the power 4 in the tan here. So now I can simplify the cosine theta here with this cosine theta, but it becomes to the power of 3. And because I'm dividing, I can substitute the division by multiplication if I swap the denominator, which is, in that case, I can swap this. So it becomes integral of cosine to the power 3 theta divided by sine to the power 4 theta d theta. And if I look at my trigonometric identities formula, I don't have any trigonometric identity where the power here is odd. All of them are even. So I'm going to transfer the cosine to the power of 3 theta by cosine square theta times cosine theta. So my integral becomes cosine to the power of 2 theta times cosine theta divided by sine to the power 4 theta d theta. And I know from trigonometric identity or Pythagoras, cosine theta plus cosine square theta plus sine square theta is equal to 1. So that means my cosine square theta is equal 1 minus sine square theta. So I can replace my cosine theta by 1 minus sine square theta. So my integral becomes 1 minus sine square theta, all that multiplied by cosine theta divided by sine to the power 4 theta d theta. And I know that the derivative of sine is cosine. Sorry, the d theta is in the numerator, not in the denominator. D theta here. I know the derivative of sine is cosine, so I say let u equal sine theta. So my du is equal cosine theta d theta. So my cosine theta d theta become my du, and the sine here become my u. So my integral become 1 minus u square divided by u to the power of 4 and du. The cosine theta d theta become du. And now it's very easy to solve. That integral, I can split it into two integrals. It become 1 divided by u to the power of 4 du minus integral of u squared divided by u4 du. So the first integral become u to the power minus 4 du. And the second, I can simplify the 2 and the 4 here. It become 2. I have minus here, not equal. So it become integral of u to the power minus 2 du. And here we use a power formula for integral. So the solution of integral u to the power minus 4 is u to the power minus 3 divided by minus 3 minus u to the power minus 1 divided by minus 1 plus c. So I have to, we don't like to see negative exposure. So it become minus 1/3 u3, and here minus times minus is plus 1 over u plus c. But remember that I took my u is equal, here, where did I take it? Sine theta. Here I took let u equal to sine theta, so I have to replace my u by sine theta. So it become minus 1 over 3 sine to the power of 3 theta plus 1 over sine theta plus c. If I want to draw my trigonometric triangle, that's my theta. We took u equal to sine theta. Sorry, before the u, I have to go back to the beginning where I took x is equal tan of theta. Here, x is equal to tan of theta. So tan of theta is equal x divided by 1. So here, tan of theta is equal x divided by 1. But I know tan is equal to opposite divided by adjacent. So that's my theta. The opposite of my angle theta is that here, which is x. And the adjacent is equal to 1. And here, if I use Pythagoras, I would have x squared plus 1. So now, but I don't have tan. I have sine theta. And I know sine is equal opposite divided by adjacent. So that formula, that solution that I have here, it become minus 1 divided by 3. Instead of sine theta, I can put opposite divided by hypotenuse, and the opposite of the angle theta is x, and the hypotenuse is x squared plus 1. But I have it to the power of 3, so it become x divided by square root of x squared plus 1, all that to the power of 3, plus, now I'm working on this, 1 over, again, sine theta, which is opposite divided by hypotenuse. It is x divided by square root of x squared plus 1 plus c. Because I have the minus 1 divided by that numerator, so I can flip 3x divided, let's get rid of to the power of 3 first, so it becomes minus 1 divided by 3, x to the power of 3, and then x squared plus 1 to the power of 3, let's keep, I can write it x squared plus 1 square root of x squared plus 1, because x squared plus 1 to the power of 3 is x squared plus 1 to the power of 2 times x squared plus 1, and x squared plus 1 to the power of 2 can go outside the square root as x squared plus 1. Plus 1 divided by x squared plus 1. Because I have the division here, I can flip the denominator and it become multiplication. So my solution become minus 1 over 3 times x squared plus 1 square root of x squared plus 1 divided by x to the power of 3 plus square root of x squared plus 1 divided by x plus c. And that would be the final answer. If you like my video, please subscribe to my channel. That would give me a lot of help. And if you push the like button, I would really appreciate it. Thank you for listening.